Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand a program which converts a given binary tree into a doubly linked list. First, let us take an example. The left and right pointers in nodes are to be used as previous and next pointers in the converted doubly linked list. The order of nodes must be same as the in order of the given binary tree. The first node of the in-order traversal must be head node of the doubly linked list. Now let us have a look at the algorithm. Let us also have a sample tree to test our algorithm. We call the binary tree to double linked list function with root node and head which we initially set to null. Since root is not null, we take another variable priv and set it to null. Note that the priv variable is static and hence the same value will be accessible in all recursive calls. Now we call the function recursively with the left child of root, so root will point to 12. As root is not null and priv is already null, we pass the left child of 12 which is 25, so root will point to 25. Again we pass the left child of 25 which is null. Since root is pointing to null, we return to the call stack. Now we convert node 25. Since priv is pointing to null, we set head as 25. Next, we set priv equal to root, so priv will point to 25. Finally, we call the right child of root which is null, so root will point to null. As root is pointing to null, we return to the call stack and finish execution for node 25. Execution for node 12 is resumed. Now as priv is not null, we go to the else part and set root's left to priv and priv's right to root. Next we set priv to root. Now we call the right child of 12 which is 30, hence root will point to 30. Next we pass the left child of 30 which is null. Since root is pointing to null, we return to the call stack. As priv is not null, we go to the else part. So 30's left will point to priv and priv's right will point to 30. Next we set priv to root, so priv will point to 30. Now we pass the right child of 30 which is null. As root is pointing to null, we return to the call stack. We finish execution for node 30. Also, execution for node 12 is over. Now we set 10's left to priv and priv's right to 10. We set priv to root. Next we pass the right child of 10 which is 15. Hence root will point to 15. As root is not null, we pass the left child of 15 which is 36. Again, as root is not null, we pass the left child of 36 which is null. As root is pointing to null, we return to the previous call. We set root's left to priv and priv's right to root. We make priv point to root, hence priv points to 36. We call the right child of 36 which is null. As root is pointing to null, we return to the previous call. We finish execution for node 36. We set root left point to priv and priv's right to root. Next we set priv to root. Now we pass the right child of 15 which is null, hence root points to null. As root points to null, we return to the previous call and finish execution for node 15. We have the final doubly linked list. Now let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.